Welcome to the Journey Shake Ham. Please do the warm-up question to the best of your ability, and we'll discuss it in a moment. You were given a description of the element chlorine. And I will go through this description and answer both question number 1 and number 2 as I go through the specifics of the description. And first of all, we're given a 2.5 gram sample of the chlorine. Well, that would be a physical extensive property. It's an amount. It could have been any size of the sample, and therefore it is extensive, physical. It has an atomic weight or an atomic mass of 35.5, and that would be a physical intensive property. That does not change no matter where I am, or I can look at any periodic chart and I will get the same atomic mass for this element. It has an atomic number of 17. Well, that's the number of protons, and that does not change in normal circumstances, and therefore that is a physical intensive property. The density of 0.0032 grams per centimeter cubed. Well, density is a ratio of the volume and the mass. Density equals mass over volume. And that does not change unless we change the conditions. But under the same conditions, we would have the same density, and that would not change. And therefore, it would be a physical intensive property. It is non-combustible. Well, that is a chemical property. It will not combust. It will not burn, and that would be a chemical property. It is a poisonous gas. That is also a chemical property. That's how it behaves with my body. It's poisonous, and that is a chemical property. In World War II, it was used as a war gas. Well, that's informational, and I suppose you could look at it being a war gas because it was toxic, and that would be chemical. So we have to be careful when we look at these and which parts we pick out as to what kind of a property that they are. We want to make sure that when we're identifying a chemical property that we know for sure there is no question about that. It can be found with oxidation states of 0, -1, +1, +3, +5, and +7. Well, oxidation numbers, that's how it behaves with other elements, and that would be a chemical property. As little as 3.5 parts per million, well, that's an amount. And amounts would be a physical extensive property. It is a yellow-green gas. Yellow-green color is a physical intensive property. No matter how much of this chlorine gas I have, it will always have that yellow-green color. The Greek term chloros, that just helps us with the relationship with that we call it chlorine from that chloros because it is a yellow-green gas. So that's informational. It can be detected as a pungent odor. Well, odor itself is a physical intensive property. And 1,000 parts per million is likely to be fatal. Well, that's an extensive amount because it says it's likely to be fatal. That doesn't mean it necessarily is fatal. I wouldn't want to try it, but that would be an amount, and that is a physical extensive property. It's widely used in making pool chemicals, disinfectants, in the pulp and paper industry, textiles, paints, plastics, refrigerants, resins, pharmaceuticals, and pesticides are a few of the ways that chlorine is used in the environment, and that would all be chemical properties. Each one of those would be a chemical property. And if you were asked to pull out 4 chemical properties, I could just list 4 of those things. And that would be a good way of doing it. Well, tonight's assignment looks very much like the assessment or test. We use a test and assessment kind of interchangeably. And tonight's worksheet looks just like one of the assessments because it used to be one. And therefore, you want to pay careful attention to the questions that are being asked. And I know that you always do your work to the best of your ability, so that's no question there. And that's all I have for you today. You'll go over the assignment with your facilitator that you had, and I can't wait to see you tomorrow. Bye.